Hello and Merry Christmas to you all. Despite the holiday, your boy has to ship a video or die trying. I have to ship a video every week. I'm out of town, but I figured I will just do a quick follow-up to last week's video, which was about Creusot, which is a formal methods specifically for the Rust programming language. There was some great feedback on that video, and so I want to address it. So one of the comments basically said, learn Ada. I think that's a fair point. Ada slash Spark, S-P-A-R-K. It's an excellent language. It has 40 years of formal verification in production systems in terms of domains where it's used. We have the aerospace domain, the defense domain, safety critical systems in general. Anyway, it's proven, it works. It's been doing this since 1983. So yeah, fair point. Same with Eiffel. It's a design by contract language, and it's been around since 1986. We also have languages like Daphne, Lint4. We have Isabel. All of those are great tools. These are not obscure tools. They are established. So the last video really was not about being unaware of these, right? Or at least it's not that I'm not aware of those, but really it was specifically about Rust and how do we apply formal methods to the Rust programming language specifically. Someone mentioned that Safe Rust doesn't have undefined behavior. This is mostly correct. I misspoke in the last video. Oh, and by the way, all the background noise is just me trying to record this while I am at my in-laws and my daughter is, well, having a field day. Anyway. So in Safe Rust, empty slice access is a panic, and it's also considered a defined behavior. Same thing with integer overflow, right? In release mode, you get a wraparound behavior, which is also considered a defined behavior. And actual undefined behavior is things like dangling pointers, data races, aliasing violations, and so on. Safe Rust, for the most part, eliminates undefined behavior. I'm not comfortable proclaiming that it strictly prevents UB. UB stands for undefined behavior, because I got tired of saying undefined behavior. Anyway, there are people more qualified on this matter than me when it comes to Rust to say that it strictly eliminates UB. However, I do know that Rust doesn't eliminate logic errors. All of this is to say, thanks to Dernet and Alice Turner for keeping me precise on this matter. One of the comments said, basically, just use option or result. I mean, fair enough. For most cases, option or result are your friends to save you from your scale issues. But they don't give you algorithm correctness. Binary search can return results and still have off by one bugs. Rust's type system definitely helps prevent silly mistakes. It doesn't prevent correctness problems though, and that's the gap. Someone pointed out that a tool like Creusot can destroy compile time. It's actually the top comment on that video, and it's not wrong. Yes, formal verification is slow. It's a trade-off. 4 times compile time, 4 months debugging bugs in production. For web apps, it's probably an overkill. However, for cryptography, consensus protocols, safety critical systems, I would say it's worth the trouble. Bugs can be more expensive than the upfront cost of verification. Someone mentioned a great list of lints from, specifically Clippy Lints. Well, I guess I should say Clippy Lint rules. And to that I say yes. I mean, yes, you should definitely use whatever is available as linting rule for your code, right? Because, I mean, they're there to catch common issues and common patterns that should be flagged as issues. Again, I guess to some degree it feels like I'm being defensive, but I guess this is all about contextualizing the video. And yeah, a formal verification proves algorithm correctness. So different tools, different jobs, but both are valuable. Definitely. Overall, I really appreciate the comments. A lot of them were thoughtful feedback, and I look forward to receiving more comments on my videos going forward. So I mentioned Ada/Spark. I mentioned Frama-C, Creusot, Daphne, and some other stuff. Links in the description. Main takeaways, each ecosystem has or should have some tools to apply formal methods, and you should use whatever fits your code base. And yeah, I think that's all I wanted to share, or I guess follow up on from the last video. And yeah, as always, like and subscribe, and I'll see you in the next one.